Hello everyone. Let's see, that's my first stream. Okay, cool. I guess let's get right into it. I have a machine learning exercise. Oh shit. My clock. Let's see. It doesn't matter. Okay. Let's see. I'm not fully sure how I'm gonna structure the live streams. I'm here joined by my friend Adam.
Hey, that's good.
So I'll see. Maybe let's open the PDF first. Software engineering, feature engineering. Let's check the thing is correct. I'll check the stream on my phone first if everything's alright. But this is my homework. Let's see. It's poor. I guess I can also send you the stream to check if everything is alright. So.
For sure.
It's kind of exciting, like starting this YouTube journey, like going and like actually doing streams and videos. Seems kind of cool.
Yeah, I'm excited to see where it goes.
Yeah, has been like a dream of mine for like a long time, but I never really found what I wanted to do and like what people are actually interested in. So, but now I feel like I know, like, I just want to find like motivated people who like want to study, learn, become better, and yeah, I like know now what I want and what I can provide. Here, so live streams, live, share, bro. Okay. Ada. Bing and send. Ooh, I could make like in the background why the fuck am I in Bing? Bruh. Because of the my PDF shit. Postman. Bzz, bzz, bzz. See, okay, I'll check the stream.
Cool desktop, by the way. Very NASA.
Yes. New pin chat. You can now pin messages. Okay, got it. Okay, let's see. Like this. Okay. Yeah, okay, nice. Okay, so the subcard. It's a bit big. I'll make it a bit smaller. Let's see. And let's see. It's actually quite nice. Thing. Okay, let's get to it. So here, PDF doesn't show up properly. This is the notebook. Let's see. I'll have to hear if I can hear myself. Let's see. I'll have to hear if I. Yeah. That's. Noise volume was fine. Okay. So we have the data set, online exam. Where, let's see, I guess, yeah. Data describe. So this is like a cheating exam. You can maybe even pull up the notes, Kaggle. Let's close this. Here, this is the exam dataset. Yeah, so 16,000 values. 1600, sorry. And the goal is to predict whether, let's see if we make this select all, apply. Here, if it's a genuine attempt or if it's a cheater. And we have like how long the exam took, results, questions. Let's see, ID. Yeah, so now what do I have to... So pick the dataset. I did that. Split the dataset into train and test validation. Test individual validation dataset. Okay. Notebook. Okay, so we have describe. Let's see. Yep. Dropping ones. I don't... Okay, we have this. That is fine. But I'm not fully sure. Like, I pre-generated some code with chatgpt. But I wouldn't say, or I have to check if this, the dropping off those 3 ones makes sense. So the student name, I guess, has no information, so that makes sense to drop. Then the result is pass or fail, so that's pretty important to keep. That's a pretty useful information to have. So I will delete that. And then prediction, I guess we remove this because we don't want that, because we want to predict that. That makes sense. So I'll delete that. Okay. X drop. Yeah. Okay. So remove useless information and remove. Yeah, and split results. But it's results. That makes that up. So it's prediction. Do we have any other useless information? Total question attempt. Those are all numbers. Fail pass. We might have to convert that, or we definitely have to convert that to 0 or 1 instead of text. And then output, I guess we also have to convert to 0 or 1. So let's see, maybe chatgpt already did that for us, but let's note that down. To do convert prediction and result. Prediction to 0 and 1. Insert text. So, okay, so we split the training. We have a temp. Okay, test. Oh shit. The auto saving. I'll have to disable that. That's really annoying. Settings. Auto. I think it's save. Auto save. Off. Like, it's a weird bug for Jupyter notebooks. At least that's what I've seen it as. Like that, the positioning goes off once it saves. Which is really annoying if you just try to read something. Okay. Let's check. Okay, so we have training. What should this split be? There's no split specified. Okay.
So just 50-50, I'm assuming?
Yeah, so I guess what's done here is test size is 30% of the whole. And then they take test size, actually train. So we have X, Y, that's everything. So train is 30% of the data. Then we have a test and a temp. No, where's the temp? Here's the temp. So it's not even 30%? Question mark. What does temp do? And then we have test validation, which is 50 of temp. Oh, okay, that's the rest. Okay. I get it now, I think. So we have training is 30% for sure. And then the rest, the 70%, gets split by 50. So test is 20. I guess 70 divided by 2. which then, you know, I like this, yeah. So it's 30, yeah, same. Okay. Yes, that is not really necessary. So test is, yeah, and validation. Okay, cool. Then I understand temp is 70. Yeah, sure. Then, okay, that makes sense. So we split that. I don't know why it's like complaining about the imports, but I know it's not a problem. Like, it's just visual. Okay, so run that. Should connect to the kernel. Same. We should see the same text pop up again. Yeah. So it's loading. Nice. Okay, yeah, that works. Then we split the test and train set and validation. Train test validation. Oh, whoa. Next up, what do we do here? I guess let's look at the sheet. So we have, first we chose our data set, the cheater data set. Then we split the data into train, test, and validation. Next, implement forward selection. Okay, I don't know what that is, but I guess it's some feature selection. Use the LDA or OLR. I already researched that or looked into it, like which I should choose, because I have a classification data set of like true or false, or a category of genuine or cheater. For me it's classification, which then is LDA. So I'll have to do LDA, linear discriminant analysis. Okay, and cross-validation score, is that the next one? Diff maximal half maximum number, initial data set. Okay, but let's see if we can find something out about this linear discriminant analysis. Forward selection. Okay, we have the X train, Y train. Those don't get used at all. Interesting. Val. Why don't X val? Sure. I don't know why. Let's see. Select features. Okay, best score. Best feature. We haven't found one yet, so we go through all the features. How are we doing that? Forward selection. Okay, so we do x.columns. Okay, that's fine. So the data columns, sure. So we go through all the columns, which, just to go back, like those, we go through all those here, the headers. And I guess I can headers. Yeah, so we print them, so we have them in a bit more. Okay, let's run and see if there's any errors. So now we can see what it selects. So student name, blah blah blah, and then I think prediction should be not. It is included. Didn't we drop them? Or data, it takes data. We didn't drop it from data. Yeah, that is X. Okay, so data still has that. Okay, sure. Let's see. Selected features. Okay, so there's an error here. Let's see. None index student name objects are in columns. Raise, self-raise, index, cross-validation, forward. Okay. It's not quite clear to me which, I guess line 14. Let's see. Scores equals cross. And this is one we imported. Okay, so this has this error. Type objects are in the columns. Could that be because it's a string? So, or is that something else? Could student name is a string? Question mark? I would assume not, but I don't know. LDA, xtrain, temp features. Okay, let's just print everything we have from before. So print, we want, I guess, F, and then we have the temp feature. We want print. Let's do LDA first. I guess LDA is just a class, so it won't give us anything. I mean, let's try. But I'm guessing that won't be of use to print that. Or I'll actually do it also as an F string. LDA. What else do we have? We have selected feature plus features. So I guess I could just print. No, let's try it for now. And I think it's complaining at the first key already, so it might just be that the code is faulty. Because the first element or the first header it selects already has a problem. Okay, yeah, like expected, just prints the class name, doesn't give us any extra information. And temp features is just a list of the first, so student name. Okay. LDA, temp train data. Ah, I see. I think I get it, because it's trying to access this temp features one, which is student name, but we dropped, I think, the student from the training xtrain. Here, x data, we dropped it. So that makes no sense to take the columns from x. Okay, that's okay. So should we just remove them, or like take them instead of headers from data instead of x? Would that be an issue? Yeah, sure. Let's try that. So instead of data, we do x.columns. Let's see what happens next. So it still gets a bunch of things. Then exam mode. Okay. So now it is still the first one, but we removed the two other features. Is it now a different error? Let's see. It's a lot more. Yeah. All the 5 fits failed. Huh. It is very likely that your model is misconfigured. You can try to debug the error by setting error score raise. Below are more details. Okay. I guess that is more complex than I understand right now. So it's ChatGPT time. So we have the code. Does that all? Probably I should bring in the other data we had before. I don't think we need anything from here. Yeah, this is just a duplicate. I guess I'll put it down so I don't lose it, but it's not necessary right now. But then we know, let's delete that. Let's move that in here. sklearn, that's fine, we drop the features. Let's move the imports up here. And then maybe the to-dos will confuse ChatGPT, but let's see. Oh my god, the lines. Well, I guess maybe it will format them automatically for me next time. Okay, so I'll copy that. And I will copy this whole thing. Guess that doesn't... Maybe that helps. And the arrows. Can I just select all? Yes, nice. Okay. And then arrow. And let's see. The error occurs, Linux model sklearn cannot handle non-numeric data. Okay, so it was actually maybe a correct hunch. Let's see. Maybe it's just getting confused because I wrote it in the to-do. Exam. No, this one is string, so it would make sense that this throws an error. Okay, maybe I was big brain. Big brain, let's see. Oh nice, it formatted it nicely. Oh, that's annoying. Cool. Let's see. Do I want to throw my code away? No. I will do a new block under it. Code. And I'll do mark xxxxx. Huh? I want to finish it. What the hell? I guess it doesn't matter. Paste. And... now it's here. I just want to quickly do that. Yeah, nice. So I have a bit more distinguished. Yeah. Okay, cool. Okay, let's just run that and see if it fixed anything. Oh, it run. Select features, but just selected one. Select features. Huh. So, was that the best feature? Exam mode. But that's the first, I think. Okay. At least there's no errors anymore, but it's still the first feature, so I'm not sure if it worked or not. Maybe it did. Okay. Let's just print out mean score better than... Let's just print out the score. Print mean score. I guess 4... Yeah. Let's see. So it ran. What happens here? So okay. Oh shit. Okay, that's a lot. Okay, so we have, instead of 4 feature, I'll just do that and do like this. It's a bit more readable. So okay, so exam mode 0.9. Okay, it does seem to be the highest. But they all seem to be pretty samey. But okay, it does seem to select the best one. But what does that value mean? So let's ask it. Perfect. Thanks. Now I get this. What do the means... or other means? Score mean. I guess the score mean. Yeah. Can you explain what it does and why I should care? Okay, the scores you see are the mean cross-validation scores for each feature being considered. Okay, let's see. Cross-validation scores. I want a visual. Is there anything? Doesn't really tell me much. Just looks like a graph. Okay. So that doesn't help. Scores for each feature being considered for the forward selection process. Here's an explanation of what the scores mean. Cross-validation score is an average performance of the linear discriminant analysis. So let's check if we can. What is linear discriminant analysis? Okay, PCA, component axis maximizes the variance. Maximizes the component axis for class separation. So separating classes before LDA, after LDA. So draws a line. I mean, I guess linear is of course a line, but what does the analysis give us? Just splitting two. Okay, so it can draw multiple lines. And just, I guess, tries to separate classes as cleanly as possible. But I don't quite understand what the difference between like a linear regression and this would be. Like, is this just linear regression? I guess I'll write that down. So, what can I do? I guess I'll write it down here. What is the difference between what is it? LDA and linear regression. I guess I can ask that chatgpt. Linear discriminant analysis and linear regression are both linear models, use different types of prediction tasks in machine learning. Okay, LDA purpose is primarily used for classification tasks. Sure. And I guess regression is for regression tasks? Purpose for regression tasks. Yeah, sure. But what is the... What is the... linear thing called that is used for because I know there's something also called linear something. I guess linear classification or something. Logistic regression? Binary classification. Ah, maybe it's this, logistic regression. Linear comparison LDA and linear regression. Okay, it's getting too wacky. Okay, I'll just note down this and I'll take it as for later. So question mark this. Okay, sure. So what were we thinking about before? So we were trying to figure out what those values mean. Total exam time. Okay, sure. Those are like how good they are. Scores here. So the mean scores, average accuracy of the model over different folds cross-validation. For instance, a mean score of 0.937 indicates that the average model correctly classified target variance of the type. Yeah, but is it just removing that and checking with it, or like how does it, or is it just using time in minutes as its only feature? Or like how does that number connect? Forward selection is a feature selection technique. Starts with no features and iteratively adds the most significant feature that improves the model performance until no further improvement is possible. Okay. I guess it makes sense. You start with nothing and then you add one. Yeah. Iteration, one, yeah. Best performance. Okay. Use cross-validation to evaluate the performance of the model with the current set of... Okay, so it's a linear thing and you just... Okay. Yeah. When adding new features doesn't improve the model performance significantly, stops. Okay. Why you should care, model performance simplicity over fitting prevention. Okay, example output, initial evaluation, future consideration performance, getting mean accuracy score. Mean accuracy score. I guess I want to watch a video about this, because I'm not quite sure what this whole number means. Like if it tests out every possible permutation with result and then means or like takes the average of that, or what that number actually means. So let's see. Let's do a live review. Where is 80? Here. Let's see. Duplicate. And let's search. Let's mute that. Holy fuck, the overlap. Oh my god. Oh, I really don't like side quest. He explains it in the most complicated way ever. Okay, wait. Yeah, normal speed. Okay, nice. Which I mean, I like him. 20 minutes though. 8 minutes. Ooh, 2 minutes for discriminant analysis. But it's not the same. But sure, let's try. Multivariate Gaussians, LDA. Oh, classify the highest density. Ooh, LDA as dimensional reduction. It's also 15. Ooh, 4 minutes. That's nice. Cool. Let's see. Wait. Let's fix the. Let's turn this off for a sec. And I'll see if I can. Take.
The boundary is determined by treating the observations of each class as samples from a multi-dimensional normal distribution. Theoretically, we could fit an n-dimensional normal distribution to the observations in each class. This involves calculating the mean vector and covariance matrix for each class. These determine the center and shape of the distribution respectively. Having fitted the distributions, we could draw a boundary between the classes by determining the set of points where the probabilities are equal. Observations on one side of the boundary would be classified as one class, observations on the other side as the other class. We can do all this theoretically, resulting in an equation for the boundary that depends on the parameters of the fitted distributions. This means that we don't actually need to go through the whole process to perform discriminant analysis. We just need to calculate the means and covariances and apply the formula for the boundary. If we assume that the distributions all have the same shape, that is, the same covariance matrices, then the formula simplifies greatly. The boundaries turn out to be linear, and the coefficients of these linear boundaries are easily calculated from the individual class means and shared covariance matrix of the observations. This makes linear discriminant analysis quick and easy to perform. However, linear boundaries are not appropriate for all problems.
Is it even? Wow. It's not. Wow. I guess that's a skip. turn on the music again. Oh, it's slower. See if the volume is fine. Probably a bit loud now. If I turn this down, does it also adjust the volume? No. Okay. I think that's fine. Yeah. Okay. So that didn't help. Such. So then I can turn. Okay, and then yeah. So, but I guess it works. I just don't quite understand what that connection is. So, what exact or how exactly is the value connect header and how is it calculated? I guess maybe we can check out the code and see if we figure it out, but else we skip. So we try to calculate a mean score for each thing, which is cross-validation score. We take the temp features and the training data, and we say CV equals 5. What does that mean? What does CV5 mean? Cross-validation score, 5-fold cross-validation. Iteration 1, training the model on folds 2, 3, 4, 5. Fold 1. This is randomly divided into 5 equal. Ah, okay, sure. So splitting the data set into 5 parts. Okay, makes sense. X-train temp features. I guess that would matter actually a lot, which score. How can the feature... Oh! So I was printing the wrong thing. That's why. Let's see. Okay, that makes more sense. So now the score is for each of the combinations. And then it takes... But how does it just get one feature? Okay, so now my confusion is a bit cleared up, because I was printing the only one out of the features, which didn't make sense to me. But now, yeah, if it takes all those headers and then it tries to calculate a value for them, then it's that. Okay, sure, makes sense. And then it takes the best one, and then that's the best feature, but it doesn't necessarily make sense, right, for features. If it's first empty and then 1, shouldn't just return the best feature combination? And why does it have so many features already? Did it just... didn't start empty? Selected features. Best feature. Selected features append best feature. Kind of confused why selected features is not empty in the first print. So let's see, return. I said it's printed from the whole time. Let's see if we can figure out something. So it's empty, but how is it already? Ah, no, okay, those are all the headers, so that's fine. Actually, make that a bit more clear so I'm not getting confused in the future. Headers. Okay, so headers, sure, makes sense. Maybe I'll also put that out like that. Or actually headers. Sure. Selected features, nothing. But how does it have so many already in the first print? Sure, interested. Console is not defined. Oh, Python, not JavaScript. Print. I really don't understand why there's so many already. This one. For feature, selected features. But this should be empty and then there's one feature. How the fuck does it have more already? Oh my god. Oh no. I don't know. I guess I'll mark that down if I'm getting too confused now. So that was a question. Why is it right having so many features when at the start, when it's, I mean, well, it should be empty. Almost empty. Yeah, don't get that. Okay, but I guess it gives us something, so I'm skipping for now. Comment that out. Did I forget? Ah, this one. I forgot to. Headers, and okay, we get one best feature, I guess. Sure. Then is our homework part implement forward selection. I guess it's implemented. Forward selection. Sure, we select one thing. Which is also kind of weird why it's only one, not more. No. Shouldn't it be more headers than just is it that much better than okay, I don't know. Maybe it's just the way most efficient or something. Not sure if can forward multipliers. Maybe it can just return 1 and that's just the best. Let's see, SQL learn metrics, accurate score. Oh. Does I guess it already converges. I don't have a, or did I set a maximum number? Or chatgpt? Yes, let's delete that. Delete. Was there a maximum set forward selection? No, not that I can see. This, I can also come that CV means it splits it into 5 lines. Yeah. Oh my god. I'm full retard. That's why. Let's see. Okay, that makes sense. It wasn't actually that full. Here. 1. Okay. Okay. I printed the wrong thing. I printed features, all the time. But I should have printed the temp features. Yeah, okay. That makes more sense then. Okay, so exam mode alone is 3.375, and then adding more things makes it worse or same. Okay, so it's just literally the best thing. But that's weird, that doesn't really say much about the date. Let's see, if we look at the data set here, exam mode. So there's, I guess, the most cheaters in remote, I would guess. Interesting, I actually want to not try that. So, if that's correct. So we have this. Let's ask ChatGPT in a new chat. I have okay. What was this? Forward selection. As the best feature combination. So I would guess. Let's see, is there anything? It's only those 2 options. Okay. So I'd guess that remote has most. Oh. So this might be a weak data set. If it's that, like, if it can just select one column out of like 15 and get like 90% accuracy. Per to center best. Can you train a model and check if that can you also check if the data set is bad / unbalanced? Okay, let's see. Cluster distribution 0, 1. But what is 0 and what is 1? Did we convert exam mode? Fit transform? Numeric values. Okay, print f x I guess there's no new exam mode equals it's self-overriding itself too fast. So from okay, it should still give the same results, but now it should print also what means. Okay, 0 to remote. No, that's just the index. But it does center. I don't quite understand. Class distribution, okay, but there does seem to be it. I guess 1 is normal and 0 is cheater because there's like way more normal ones. Figure here. Prediction here, like genuine. It's like most of them are genuine. And then there's one cheater, which I guess is this here. So basically almost all of them are genuine. rerun that, and then I'll paste the results into chatgpt to explain. Okay, classification report, precision recall and F1 score. So for class 0, precision 0, the model made no correct positive predictions. Recall, model failed to identify true instances of class 0. Wait, what the fuck? 0, 0, 0, 0. I see. Okay. So no accuracy for 0, okay. Then for class 1 gets 69. No, 96. 96% correct. Recall 1, the model correctly identifies instances. Okay, so perfect. Gets all of them. Recall. And then, okay, so for class 1, it like almost gets all of them, like 100%. And then for 0, it 0%. Nice. Accuracy, total prediction. Macro, average, precision recall, across without considering imbalance. Confusion matrix, the model prediction, 0 instant. Key insights, okay, class imbalance. There's a significant class imbalance in the dataset with class 1, presumably non-cheaters, yeah. Having instances class 0, presumably cheaters, 77 instances. The imbalance likely impacts the model's performance, causing it to be biased towards predicting. So it basically just predicts always 1. Nice. I guess that works for a good accuracy. The model performance will predict class 1, shown a high precision recall. Yeah, not able to yeah, okay. Process about cheating behavior given the imbalance, the model tendency to 0 is not effective discrimination. Okay, recommendations. Address class imbalance. I guess we can't do that because we don't have any new information. How can we do that? Use techniques such as oversampling the minority class. Yeah, but we don't have undersampling the majority class. Like similarly majority oversampling to Oh, so you could pick more of the 0 ones, basically duplicating them. Sure. Feature engineering, consider adding more features. Yeah, okay. So this one is not possible, we can't add any features. Or I guess can't add any rows. Features, we could do more, but yeah, sure, features we could add more. Model evaluation, different metrics. Okay. I like those recommendations. Ensemble methods. Consider using ensemble methods like random forest. Okay, sure. I like that. I guess I'll put that right after here. Markdown. And then we have the problem class imbalance. Only how many cheats do we have? Like 77 or something? What was this? 0? 77, yeah. 77 out of 1,600 cheaters. Okay. Interesting. Okay. What is... So I guess it converges? I'm not sure what that means. Yeah, so that is... I figured that one out. That was my bad. Just printed the wrong feature, the wrong variable. How it is connected to data. Okay, that makes sense now. It's just taking all of them. Yeah, I was just printing the wrong stuff, so that's why I was confused. I still don't know that. I still don't know the connection between this. That's still open. Yeah, okay, that is clear now because there's the class imbalance. Yeah, so that is correct. It is much better alone than with other features. Yeah, it can. Okay, so that is equal yes, and that equal yes. So it can be more headers, but it's just imbalanced. So it should be more headers than just exam mode, but it's not because the dataset is way unbalanced. Way too unbalanced. It's better alone. Alright. Alright, then I cleared that up. Okay, so one. Cool. I learned. Okay. I don't understand. What does that mean? I did not have to do that, so that is no. How I explain? No, and then I think how would I set a maximum? I guess I could just do like an if statement and just stop prematurely if there's too many features or something. So probably just with an if statement because I'm coding it myself anyways. So I guess it's a trivial question. Okay, so maybe I'm already finished soon. So classify regress with the initial data set and print out the quality measures and results of with forward selection. Okay, so this is just doing what I already did down here. So I'm done. Nice. Does this work? Metrics, try. Okay. Yes, it's fine. Sure, cool. Then I'll submit my code. We'll just have to put that all into one code and this one. I guess those imports are mostly duplicated, but let's see. Ah, that might be an issue. Data. Are we changing data at all? Data. Yeah, but we're already doing that. Results. Nice. This is duplicated, this is duplicated, this is duplicated, this is duplicated. Do we have the cross-validation score? No. That's the only thing we need to add. So here. And then this data result prediction, I think this is duplicated. Data result is the same. Yeah. So we can delete that. Is this duplicated? Yup. Delete that, delete that, delete that. Forward selection, that is new. Okay, X, Y, this is duplicate, but I guess we would do X equals data and then selected features. So duplicate. And then the output, of course, is prediction. Yeah. Then we calculated X, Y, new training set. Does it make sense? X train, Y train. I guess doing this doesn't really make sense if we calculate a new version. So shouldn't I just take everything? I guess it makes sense to drop the X, but then not use this, but actually select X. I'm not sure if I'm mixing the data sets in a way that shouldn't be allowed, but for me it does make sense to use everything. Maybe that's bad practice, but I'll do it now. I'll do it. Y, okay, we use the full data set, we used it, yeah, X. Okay, yeah, that makes sense. And then we split after. But Y is already prediction, so that makes no sense. And Y is X. Just one. I don't think that works like that. Let's see. Maybe it does. Print X and then exit. I'm not sure if that works in Jupyter Notebooks. Let's see. What the hell? Kernel died. Okay. I guess it doesn't like that. Not sure if that worked. Maybe it did. But why does it have this? I don't know how I can stop it. I guess you can just comment out the rest instead of exiting. Restart kernel. Ah yeah, I guess if I exit I completely stop the kernel. But let's see, if we take more instead of this being exam mode and one more, does it still work? Or does it break? Yeah, it does break. So that's bad code then. I guess make new eggs only. That doesn't work though. I guess it's getting confused because it's commented already here. Wait, does that work? Let's see. Do we have an example? Which was pretty good. 3-7. Sure. I like this one. Let's take this. And let's see if it breaks. Key error. I think that's. Let's see. Wait. Finished? Oh, so it does work. Okay, cool. Then y is already defined. Do we need y to be predefined? Yeah, we need it. But I guess we can do that down. So let's define that here. Oh, it's too far. This one. So we load the data. With the headers, we define x and y. Then we get the new selected features. We do a new x. That's fine. Then y is still the same. And then we can create the train and test set. Linear, did we already do that? I guess it's fine. Wait, I think I jumped too far. Yeah, fit, predict, classification report. Oh. Okay, let's run the code and see if there's anything breaking. That's already it? Let's see. Run again. Okay, sure. I think then I'm done. Copy. Put that in a submittable. Do we even need Seaborn? Nah, I'll leave it in. And what else? We got that. Okay. Sure. Then I guess the task being done, I will end the stream. It was a nice first experience. Let's see. I guess I can quickly recap what we did today. So we chose an online tutor exam with 1,600 values and tried to predict or classify with a machine learning model if there's a cheater or not. And one thing we figured out now is the data set is quite not ideal, I guess, because it only has data points for 77 cheaters, which makes the data set quite unbalanced. So the model we trained kind of always just predicts that it's not a cheater, and then it gets like 96% accuracy because there's so few outliers, or like 77 is quite little. So we have to change maybe some metrics in the future to make those 77 cheaters matter more in our evaluation. But for now, for this homework, we're good. So I'm gonna add some comments to the code later by myself and submit the homework. Okay, then see you guys next time. Bye.